Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, implement queue using stack. So let us first read this question, then about the constraint, then finally intuition behind the same, and then the coding and time complexity for the same. So first about this question, so I require to implement the first out, that is V for queue. That is simply a queue where whatever comes first, that goes out first. That is the thing that is there. So that is the thing which we are required to implement. And this we are required to implement using only two stacks, means not more than two. Could be one also. But uh, so here the thing would be that only two stacks would be used. Then that implemented queue should support all the functions of a normal queue, that is push, peak, pop, and empty. So this is the thing. Basically required to implement our own data structure. That is the thing here. Then the thing which would be here is implement this my queue class. The first function which is this push. So pushes element text to back of the queue, and then pop removes the element from front of the queue and returns also the same. Then P, it's about return the element at the front of the queue. Uh, yeah, and then boolean empty just to return true if the queue is empty, false otherwise. So that is the thing here, means these four functions which are there, which are required to be implemented here. Now comes the part that you must use only standard operations of the stack, which means only push to top, peak pop from the top, and size is empty. These are the only valid operations, independing which may not be supported natively. You may simulate stack using a list queue, that is doubly ended queue, as long as you use only a stack standard operation. So basically implementing a queue using a stack, but all the operations which are there, that should be those standard operations only which are supported in stack. Now comes the part for the constraints which are there. So as the constraints which are there, x which is there, that would be from 1 to 9 only. At most 100 calls could be there for this four operations. Basically, these are the functions required to be implemented, and all the call to the pop and peak are valid. Valid, they want to say that there would be elements in that particular queue, then only pop and peak would be implemented, else they won't be implemented. So that they meant by valid. Now comes the next part, that is okay, follow for the same, that can you implement the queue using such each operation is amortized order of one time complexity. In other words, performing n operations will take overall n time, even if one of those may take longer. So that's the thing which we are required to implement. So here they have already mentioned that we are required to use two stack, and using those two stack means using these two stack we are required to implement the queue. And stack, we all know that how stacks are. If this is 1, 2, 3, then surely the output would be 3, 2, 1. But if it is 1, 2, 3 in this queue, then the output would be 1, 2, 3. So using two stack, we can easily do that. Like 3, then it would be at the bottom, then 2, and then 1. And then Here the output will become something like this. That's why using two stack will easily able to convert into a queue. So now let us go ahead that how we are required to implement the same. So yeah, if we see here, use the two stack, stack one, stack two, is there. Here, uh, first function which is there, that is this push which is there. Then we are pushing to our first stack. That is the thing. So push operation performed. Now comes the part about pop. So popping from and pop should be the element which is being at the top. But here the pop exactly means that the element which was pushed at the starting to the queue. So for that purpose, we will be checking that if our stack 2 is empty and our stack 1 is not empty, then in that context, we will be checking, we will be pushing whatever is there at the top of the stack. This thing we will be ongoing until our stack 1 becomes empty because we are going to pop out from the stack 1. We all know that if two stacks are there, so if one, two, three are there, then while we are pushing here, so what will come to the top would be one only, means the element which was pushed at the starting. And this is what we require in our queue also, means this would be pushed out. So that is the thing here. And because of this thing only, we will be easily able to succeed with that this operation. And if this is not the case, means a stack 2 is not empty, means stack 2 still have some value, then in that context, whatever is at the top of the stack 2, that we will be popping out and returning that as a value. So that is the scenario here. So this was for the pop. Now comes the part for the other functions which require to implement, that is peek and empty. So a peek simply means that what is at the top, means what is the first element which was being pushed to our queue. So for that purpose again the same thing would be done the way it was for the pop. But the thing here is that we won't be popping that out. That is the only difference which we are required to do here. Because here we are required to just tell that what is at the top. We are not required to just pop it out. We're just required to keep that element as it is. But the thing would be that we require that this element should be means this element should be there only, and we are just required to tell that which is the topmost element. So that's what we are required to do here. Now comes the part, our last one, that is it is empty or not. So we will be directly checking that both of them are empty, then surely it is empty. Else, if any one of them would be having some element, then that simply means uh, that our queue is not empty. So that is the thing, and that's why we are doing things like this. So the time complexity and space complexity. So as per the space complexity, we can see that this order of n, right? But comes the part for the time complexity. So here, this push operation is order of 1, right? This pop operation, that is aim of 5 is order of 1, because here we are popping out until this stack exists. So that's the scenario. And here it is already order of 1, but here it is aim of 5 is order of 1 because of this scenario, means this scenario. And same goes for the peak operation as well. This peak operation also it is order of 1, but amorphized order of 1. And just the empty, it is directly we are checking that it is empty or not. So all operations here are order of 1 only. Uh, yeah. And they have already asked us to perform all these things in that way only. So yeah, this was all for the same. Any doubt you could comment out, and yeah, this was all. So yeah, thank you.